So the boundaries for the East Helena model were set based on physical boundaries in the Helena Valley. To the south, it's based on a potentiometric contour line, so a water table elevation in the aquifer. So we set that as a boundary on the south side of the model because groundwater flow is moving across that boundary, and we used aquifer properties, so hydraulic conductivity, and a natural gradient, so how steep the groundwater table is, or the water table is, across that boundary to set how much groundwater flow is moving across the boundary. To the west, it's set to 10 Mile Creek, which is a creek that runs along the west side of the Helena Valley. So we use the creek in this instance because we assume that that would be a divide for groundwater flow. And so a divide for groundwater flow means that groundwater doesn't move across that boundary. It can move parallel to that boundary, it can move to that boundary or away from that boundary, but it doesn't move across that boundary. And so that's why we set that as the boundary on the west side of the model. To the north, it was set based on Lake Helena. Lake Helena is a discharge point, so groundwater flow is moving to the lake throughout the Helena Valley. And when it reaches the lake, it discharges to the lake and then moves eventually to the Missouri River north of the model domain. And then to the east, it was based on the Spokane Valley Fault, or the Spokane Fault. And it was, these model boundaries are set at depth too. So the Spokane Fault, there's groundwater moving across that fault. And so we set that boundary from ground surface to about 300 feet below ground surface to the bottom of the model. And the same goes for the boundary to the south, where we set that from about ground surface all the way down to between 200 and 300 feet below ground surface in the model. Now the Lake Helena boundary and the 10 Mile Creek boundary to the north and west, those were just surface water features. And so we set those boundaries just in the first layer of the model, the upper 25 feet of the model. So the depth in the model is based on the aquifer fill material in the Helena Valley. And so there have been studies in the past that show the Helena Valley fill goes anywhere from about 300 to 600 feet deep out in the valley. And so we base the bottom of our model on where bedrock and alluvial systems meet.